All right, this is the time in the grade 11 U course where you guys learn about the inverse of a function. Now, a common theme throughout this and last unit is that you guys learned how to multiply, subtract, multiply, divide, add, subtract rational expressions last unit. We kind of do, and now we're learning about inverses, but we're doing it all in the context of quadratic functions. So when you guys take grade 12 functions next year, you'll be able to take all these skills you've learned and apply them to new functions. But today we're just going to stick to lines and parabolas. So what is the inverse of another function? So I think first week of the course, when we talked about what a function is, so you guys learned a function's like a machine. You put in an x value and it spits out a y value. Today we're learning about the inverse of a function, which basically kind of turns around or undoes a function. The inverse of a function asks what y value do you what y value do you need to put in to get the original x value. It just kind of turns things around. So we're going to do a few examples where we find the inverse of a function, and then first one is a line, second one's a parabola, and then the third one is another step up. We'll ramp things up as we go. All right, so we're going to find inverses 4 different ways to hopefully solidify what's happening. So the first way we're going to do it is we're going to do a table of values. Now, if you guys are okay, we're just going to make a table of values, and we'll just do the mental math. So we're working with this linear function, 2x plus 1. So multiply the x values by 2 and add 1. So that means when you plug in x equals -2 into the machine and use the rule, 2 times -2 is -4, and then you add 1, -3. And then, this should be a -1. My apologies. We don't want to have 2 1s there. 2 times -1 is -2, and then you add 1, you get -1. And then 2 times 0 is 0, you add 1. We're just going up by 2 every time. Can we actually graph this at the same time to see what we're working with? You guys have those 5 points there, but also, you guys can just graph these lines from your grade 9 course. But let's fit what we have on here. So -2, -3, go away, -2, -3, -1, -1, 0, 1, 1, 3, and 2, 5. I have the luxury of my straight line tool, so I will use that. All right, so we're back in grade 9. We got a linear function, made a table of values, made a graph. We're going to ask, what is the inverse of this function? So the inverse of this function just swaps. We swap the x and y. So in your table on the right here, if you want to get the inverse of f of x, what function undoes, turns the y values into x values, you just literally switch the x and y around. So that's okay.
Can I have Kimberly work to do services?
Sure. And we'll just do that all the way down. We'll swap the x and y. What value gives of x gives you a y value of 1? It's 0. What x value gives you a y value of 3? It's 1. We're just switching the x and y values. That's what an inverse is. It just undoes things. It switches the x and y. And 5, 2. Can you guys graph those 5 points? What kind of function is the inverse of a linear function? What does it look like when you swap the x's and y's? You graph those 5 points, and then we'll have a couple interesting talking points. So 5, 2, 3, 1, 1, 0. That one's the same. That one's the same. So this is interesting. Did you guys get another line? It looks like it, right? They all line up. No pun intended there. I'll draw a straight line through this one.
Sorry, did you scratch in?
That's okay.
Will we edit with it?
She's not in class right now.
Okay, thank you.
Okay. I guess you guys are doing course stuff, right? Can you guys do me a favor? Because we have two lines here. I'm going to label my top one. That's our original function, f of x. And this one we just drew, that is our inverse function. And I should have mentioned this earlier. The notation we use for the inverse function, we use f with a superscript of -1. That's kind of the symbol we use for inverse. So there's a few things to note here. The first thing to note.
Sorry about you again. You have Nina Harris there?
Yep.
She comes to student services?
Yeah, she'll come down.
Thank you so much.
They only have 2 people in there. How can they meet with 3 at the same time? We will carry on. Hopefully they don't steal everybody. Let's continue. Where was I? First thing to note. And this is true all the time. Can you guys jot this down? The inverse of a linear function is a linear function. Hopefully you guys are convinced of that. When you swap the x's and y's of a linear function, you just get another linear function. The second thing I want you guys to notice is that there's a bit of symmetry in that diagram. Now, it's not like flipping left to right, and it's not like flipping up and down. But can you guys just all tilt your heads a little bit and convince yourselves that if you tilt your heads a little bit, there's like a reflection there, right? It turns out, and I'd like you guys to add this to your diagram as well. This is the last thing we'll add to make it not too clunky. I'm going to make a dashed line along the line y equals x. So what do I mean by that? So maybe I'll start at like 0, 0. And I'm just going to make a dashed line. It kind of just goes up 1 over 1. This is the line y equals x. Y-intercept of 0, slope of 1. And I'll do that the other way as well. Do you guys see how the original function and its inverse, when you swap the x's and y's, what happens is that function just gets reflected. You can almost think of it as like a reflection in this line y equals x. Can you guys tilt your head and see how that works? This is true all the time. When you swap an x and y and you create an inverse function, it's a reflection in the line y equals x. Can you guys add that where we have some space? Maybe up here. The inverse function is, we'll just say this and keep it brief, is reflected in the line y equals x. I'm spoiling a question for Monday, so you guys can lock this in. This answers a question on an assignment for Monday. Of those 5 points, do you guys see the point that actually didn't move at all? The point was on the original function. It was also on the inverse function. Do you guys see what point that was? Which point of our 5 was it? One of those points was on the function and its inverse. You guys see? Too easy? The point -1, -1, right? Because -1, -1 is on this line y equals x. If you swap -1 and -1, do you not get the same point? So any point that has an x value and y value that are the same, it's going to be on the original function and the inverse function. All right, so we've found the table of values for the inverse function. We've graphed the inverse function. It's clearly a line, but what's the equation of that line? So I'm going to show you guys how we can get the actual equation for the inverse. And it all comes down to swapping, interchanging x and y. So can you guys follow along here? We're going to start with just rewriting our function in y equals notation. So we're just going to write y equals 2x plus 1. We're just going to rewrite it using y equals. I've been saying over and over again, to find an inverse function, it's like swapping x and y. Can you guys, we're going to literally do that. We're going to swap x and y. And then that is the inverse. We'd like to see what equation of line that is. We're going to, at this point, solve for y using our algebra skills from our grade 9 courses. We're going to move this positive one over, and we'll subtract it. So that's x minus 1 equals 2y. And then to get the y by itself, we'll divide both sides by 2. Once we get y by itself, we're left with this. X minus 1 divided by 2 is equal to y. And that is the inverse function. We have found the inverse of this line. It is the linear function x minus 1 over 2. Or, if you prefer, you could write that as 1/2 x minus 1/2. If you guys look at our graph, does our inverse function have a y-intercept of about minus 1/2, or exactly minus 1/2? And does our inverse function have a slope of 1 over 2? And you can see that it does. Look, that graph, that inverse function, has a slope of 1 over 2, and its y-intercept is 1/2. So we can get the equation for an inverse function by swapping x and y and just solving for y. We can all do it. The final way that you could think of an inverse function is using opposite operations. Let me show you what I mean by that. So in the original function, we started with an x value. And the rule of the function, 2x plus 1, says multiply by 2, take that x value, multiply by 2, and then add 1, and that gives you your y value. That's literally what the rule says, 2x plus 1. If you want to get the equation of the inverse, you just start with the y value and work your way backwards. So if you guys had to go from the bottom and then work your way back up to the top, so what's the opposite of adding 1? You guys can just somebody can just subtracting 1. And the opposite of multiplying by 2 would be dividing by 2. So if you want to get the inverse function, start with your y value and work your way back up. We subtract 1, undoing what the original function did, and then divide by 2. Divide by 2. And that gives you your x value. And if we literally just put that together, squeeze this in here, subtract 1, divide by 2. Guys, is that not exactly what our inverse function above did? Subtract 1, divide by 2. 4 ways we can get an inverse. From a table, from a graph, swap x and y. Algebraically, swap x and y, solve for y. You can also think about it just using your knowledge of opposite operations. Big idea number 1, inverse of a linear function is another linear function. Anything you guys want to chat about so far? I'd say the algebra, not too heavy right there. It's mostly our grade 9 stuff and just rearranging formulas. All right, so the inverse of a linear function was another linear function. What about the inverse of a quadratic function? So here we're going to look at the inverse of f of x equals x squared plus 3, doing all the same stuff. We chose a pretty simple quadratic function to work with. So making our table of values should be pretty quick. Note again that I forgot the negative on that -1 there. But this is a pretty easy rule to use. So square -2 and add 3, that would be 7. -1 squared is 1, plus 3 is 4. 0 squared is 0, plus 3 is 3. And then 4, and then 7. Let's graph that parabola, and then I'll let you guys discover when you swap the x and y's what the graph of the inverse of a quadratic function looks like. So we have -2, 7, and -1, 4, 0, 3. Yes, that all looks pretty good. Yeah, this will work out really good, really nice. And that was the original function f of x. Okay, I'm going to do a quick tour, check on and pause the video, check on my 3M people. You guys do the table of values and graph the inverse and see what you get. All right, here I come. We're going to get the inverse. We're going to swap the x's and y's. All right, and what does this graph look like? So we have 7, 2, and 7 minus 2. Can you guys sketch this curve too? All right, this is the inverse, f inverse of x. Did you guys get that too? A sideways parabola. Can you guys just also add in our graph that dashed line y equals x? Just to illustrate, again, tilt your head a little bit. These two functions are reflections. The function and its inverse are just reflections in that line y equals x, because we just flip-flopped x and y. Notice that there are no points on the original and the inverse because there was no points where the x and y was the same. And this is where I have my second note for you guys. Think back to, it's almost like the second or third day of the course. This inverse, this sideways parabola, is it even a function? You guys remember the test we have to see if things are functions? We had who remembers that test? I see it. We had a Lily. What's our test? Vertical line test. This fails a vertical line test. For these x values past 3, there's more than one y value. So I want you guys to add this little note to the bottom. So we saw the inverse of a linear function was a linear function, but that's not true with quadratic functions. Light purple, a terrible choice. The inverse of a quadratic function is not a function, which is pretty crazy. Well, if it's not a function, then what's its equation? We're going to investigate that in a second. All right. What is the equation of this weird sideways parabola? How does that even come about? I'm going to show you guys. Hang on to your butts. Let's dive in. Key idea, we're going to interchange x and y. So my 3U people, follow along. We are going to start with we're going to rewrite our function as y equals x squared plus 3. We are going to swap x and y. X equals y squared plus 3. And we're going to solve for y. It's not too bad here. Bring the 3 over to the left. You're going to subtract it. X minus 3. Now here's 3U people. Of course, you guys are locked in all the time, but lock in especially now. If I gave you guys an equation like this, let's say I said 9 equals y squared, and I said solve that equation for me, what would the solution or solutions be to that equation there? Sullivan, you can jump in. Three, yeah, 3 is the solution. Is 3 the only solution? Call that? Negative 3. We can't just square root to do an opposite operation here because that would only give you the plus 3, but we know that there's 2 solutions, plus and minus, in situations like this. So what we end up getting is the inverse function isn't the root of x minus 3. It actually looks like this. When you solve for y, you have to consider the positive and the negative, almost like the quadratic formula. So an equation for the inverse would look like this. It's not the root of x minus 3. It's not the negative of root x minus 3. It's actually both. It's kind of like 2 functions stacked on top of each other. That's this is like probably the crappiest equal sign I've ever drawn in my life. I think I'll tidy that up. Wild stuff. All right. How could we get that using opposite operations? I'd like us to do that as well. So the original function, what did it say? You take an x value, you square it, you add 3, gives you the y value. That's what that rule said, x squared plus 3. How do we arrive at our inverse? We start with our y value and we do the opposite. The opposite of adding 3, subtracting 3. The opposite of squaring is square root. Can you guys pretty please, though, add in brackets here? I'm going to put plus or minus as a visual cue that when you square root, you have to consider the plus and the minus, just like how y squared equals 9 has 2 solutions. And that gives you the x value. Now, if you took my right-hand little flow chart there and made it into an equation for the inverse, it would look like that. You take x, you subtract 3, and then you square root, remembering to take the plus or minus. What does that graph look like? It's 2 graphs in one. It's a plus and it's a minus. It's not an actual function. So kind of wild stuff for you guys. Things really escalate when we're talking about the inverse. But that's a nice quadratic one. Quick pause. How we doing, 3U people? It's swapping x and y. That's really what it is. Now we do have to consider one more case here. We understand now the inverse of a parabola is like a sideways parabola. It's not a function. But how would you get the inverse, the equation of the inverse for one like this? X squared plus 6x plus 4. Is there a single x here for us to just rearrange and get by itself? No. But it'd be really nice if somebody showed you a skill that actually takes functions like this and puts them in a different form where there is only one single x that we could isolate, right? Now, fortunately, we reviewed that yesterday. We can complete the square here to get a different version of this function with a single x that we could solve for. So, and I pinky swear promise you guys that I will never, when I'm asking us to find an inverse, I will keep this a value of 1 to keep the algebra pretty simple. But we have to use our method 2 that we learned yesterday. We have to have the x value 6 and then square it. 6 divided by 2 is 3, and when you square it, you get 9. So our original function, x squared plus 6x plus 4, we can rewrite it like this. We're going to add 9, but we have to subtract 9, or else we change the equation. I want to keep that pink to show that it was original. OG. And then we have cooked the books. So this is a perfect square trinomial. Things that add to 6 multiply to 9, x plus 3, x plus 3. So we have x plus 3 squared, and negative 9 plus 4 is negative 5. That is something that I can switch the x and y for and solve for y. So let's do that now. So over on the other side, let's find the inverse. Our starting point, before we swap x and y, we'll just write things in terms as y equals. Let's swap the x and y. And then we'll get y by itself using opposite operations. You guys can all do this. I really believe that. Everything's manageable. Let's use our grade 9 skills and solve for y. Opposite operations. We got to add 5 to both sides to get rid of that minus 5. So x plus 5 equals y plus 3 squared. The next thing we have to do is undo that squaring by square rooting. But now you guys know that just wouldn't be the root of x plus 5. We have to consider the plus and the minus. And the final thing is we have to move over, the last step is move over this 3. This is the only difference from the previous question. And What I'm going to do intentionally here is instead of subtracting 3 off the end, I'm just going to write -3 out front. That's traditionally how you would see this inverse written. And we got it. We used opposite operations. We added 5, we rooted, and then we took away 3. And our inverse function, or our inverse of our original function, is we would write it as -3 plus or minus the root of x plus 5. And we understand that its graph would be a sideways parabola, something like that. That's as complicated. Forrest, Sam, you with me here? Okay, not convinced. That is as complex as I will evaluate you guys on finding inverses. Okay, now we've done a lot so far. Anything you guys want to chat about? The algebra is, I really believe you guys can do it. It's just our grade 9 stuff, plus yesterday's completing the square. I would suggest once we get to practicing, you guys dig out a couple of these and make sure you try those for sure. All right, so let's finish this off. I'm going to tie things back to your grade 9 course. So Bort sells amulets that protect you from Wi-Fi and bad energies. Apologies if you are wearing an amulet like this right now, because of my comment here. John Tavares wears these amulets, so that's why I made this question. Let's say Bort is selling his amulets. He makes $600 a week, just no matter what. No matter how much he sells, $600, and then he makes 5% of however much he sells. This is actually something that would be lifted right out of like EQAO, except they would be just more diplomatic and he'd be selling like furniture or something like that. If you want to get an equation that models Bort's earnings, it's actually pretty straightforward. He gets $600 and he gets 5% of what he sells. And to get 5% of a number, you multiply by 0.05. And we're saying that the amount he sells, we're using a little a. A little s looks too much like my 5s, so I avoid that when I can. Let's find the inverse of this function. Now in grade 9, you guys were actually already finding inverses. It just, nobody told you were doing that because it would have blown your mind because you guys didn't even know what functions were at the time. Let's algebraically determine the inverse. All that means is we're solving for a. We've got our linear function. We're going to rearrange it to get a using opposite operations. So here we go. You bring over the 600. We get e minus 600 equals 0.05 times a. And then to get a by itself, divide by 0.05. Maybe you're saying, why did we leave this one to the end? This one's actually pretty straightforward. Yeah, it is. And it's just tying in some grade 9 stuff. It all connects together. So those two functions, the function for earnings and the function for the sales that gives you the earnings, those are inverses of each other. They're both linear functions. And this one shows you, it gives you, I will say this. It gives you the amount Bort needs to sell. Which is A. To make a certain amount of money. I'll say to achieve certain earnings. E. Literally a grade 9 problem. I just wanted to tie it in to show you guys you've been doing functions for a long time. So the original equation, you put in the sales, it finds his earnings. The inverse equation gives you his sales for a certain earnings. He wants to earn $1,000. He puts in 1,000 and cranks out the amount he has to find. All right, 3U people, I just put your practice in the same handout. So I've got a few different types of questions. In this first one, note that I've given you guys the line y equals x. The expectation is that you guys just swap the x's and y, and you understand the graph of an inverse will be a reflection in the line y equals x. So you guys can give those a go. And then I also have some just algebraically finding the inverse. So they're all similar to examples we did. Just give them a try. I have full solutions posted in the news feed for you guys to check. I have more practice available, but this will be enough. We have 25 minutes. If you finish a few minutes early, just help the people around you. I think I might actually pull up my solutions and just maybe around 11:10 just talk about a few things. But now everybody has something to work on. I'll tour around. I'll end my video actually. And then I'll tour around and